Matter and energy. Today we're going to look at the structure of atoms and element identity. So for your study guide, you can click here and there's a hyperlink. It will open up to a page that looks like this. So matter and energy. We have three subatomic particles to an atom. So protons have a positive charge and they're located in the nucleus with a mass of 1 AMU. So here you have your positive protons inside the nucleus and they have a mass of 1. Your neutron is neutral. It's also located in the nucleus with a mass of 1 atomic mass unit. So these would be your neutrons that are neutral. They don't have a charge. They're not positive or negative. And again, they have a mass of 1 atomic mass unit. The electron has a negative electrical charge. It's found in the electron cloud and has a mass of 0.0005, or we just say that the mass is so small it's not considered when taking in account for the mass of the atom. So here are your electrons. They have a negative electrical charge. They're found in the electron cloud, and remember, they're so small they hardly have a mass. Atoms. The smallest particle to which an element can be divided and still has the properties of that element. Nucleus is the center of an atom made up of protons and neutrons. The electron cloud is the region around the nucleus where electrons may be found. Atomic number. The number of protons in the nucleus. So this number above the symbol is called the atomic number, and it tells you how many protons are in the nucleus. The atomic mass is the average mass of one atom of an element. It's the protons and the neutrons together. And when you round the atomic mass, you get a mass number. Valence electrons can be found in the outermost shell. It determines chemical properties such as reactivity. So these are your valence electrons. They are involved with chemical reactivity. Remember, all atoms want to have 8 valence electrons in that outer shell to be stable. So if they do not have 8, they will react chemically to get 8. So let's look at the odd one out. We're going to drag and drop the red oval over the word that does not belong in each row. So a proton, element's identity, positive charge, mass number. So here, what doesn't belong is the mass number because protons identify an element and protons also have a positive charge. Remember, your protons are located in the nucleus. Proton, electron, 1 atomic mass unit, and neutron. So here the electron does not belong because we know protons and neutrons have a mass of 1 atomic mass unit. Electrons so small they hardly have a mass. Neutral charge, neutron, electron, nucleus. Again, the electron does not seem to belong because we know neutrons have a neutral charge, meaning they do not have a charge. So those would be the blue neutrons here, and they are located in the nucleus. Mass number, 0.00545 AMU, a negative charge, and an electron. So the one that does not belong here is the mass number because electrons have a negative charge and they have a very small mass. So mass number, remember your mass number is going to be the rounded number that consists of your protons and neutrons. So mass number, proton, neutron, the one that does not belong is your electron. So let's describe the structure of an atom, including the masses, electrical charges, locations of protons and neutrons in the nucleus, and electrons in the electron cloud. Read each statement below and drag and drop the subatomic particle card to identify each statement. This particle determines an atom's atomic number. So the atomic number is the number of protons. This particle is important for chemical bonding. That would be your electrons, and I would even say valence electrons. This particle is located inside the nucleus and has a neutral charge. That's going to be your neutron. This particle has a negative charge and less mass than a proton. That would be your electron. This particle determines an atom's properties, chemical properties. So those would be your electrons. This particle has a negative charge. That's going to be your electron. This particle is located inside the nucleus and determines the atom's identity. Protons identify an element. This particle is located in the cloud that surrounds the nucleus. That is an electron. This particle is located in the nucleus and has a positive charge. Remember, protons begin with a P, and so does the word positive. This particle has almost no mass. That would be an electron. So we did something wrong. This particle has almost no mass. That's an electron. So let's review to see where we might have a mistake. So protons, a particle that determines an atom's atomic number. Yes. Electron, the particle is important for chemical bonding. Yes. Neutron, this particle is located inside the nucleus and has a neutral charge. This particle has a negative charge and a less mass. Yes. This particle determines an atom's chemical properties. Okay, we might just have to change that. Electron, this particle has a negative charge. Proton, this particle is located inside the nucleus and determines the atom's identity. Electron, this particle is located in the cloud surrounding the nucleus. Proton, this particle is located inside the nucleus and has a positive charge. And this particle almost has no mass. So we could change this, and we're going to say that this particle determines an atom's chemical properties. We can say the valence electron. All right, going to the next slide, we're going to drag and drop the name cards to identify the components in the diagram. So let's look at A. A is pointing to the atomic number. Now this number tells you how many protons are in the nucleus. Okay, it also tells you how many electrons are in the electron cloud. B is what we call the atomic mass. That's the combination of the protons and neutrons in the nucleus. And C is pointing to the name of the element. And D identifies is the, let's see, that would be your name of your symbol, D. And this would be your chemical symbol, what C is pointing to. So identifies the element. That's going to be your atomic number of protons and neutrons inside the nucleus. That's going to be your atomic mass. Okay, we're going to drag and drop the numbers in the table to identify protons, neutrons, and electrons for the elements. Some have been done for you, and then we're going to drag and drop the number to answer the questions. So here we have a periodic table hyperlinked. You're just going to click on this and it's going to open up your periodic table. So we're going to be looking at iodine first, and we want to know how many protons, neutrons, and electrons there are. So I'm going to go open my periodic table and I'm going to look for iodine. Now, the atomic number, the number above the symbol, tells you how many protons and electrons you have. Okay, so let's go back over here. And so my number of protons is 53. Notice how it's the same as my electrons. That number tells you two things. Now, to find your neutrons, okay, what we're going to do is look at our ape-man strategy. Remember, to get the number of neutrons, you're going to take the mass number and subtract that atomic number to get your number of neutrons. So going back over and looking at iodine, we want to round 126.9, which would round to 127. And we would take 127 and subtract 53. So again, 127 subtract 53, that's going to give us our number of neutrons. So we can put that in the chart. So our number of neutrons is going to be 74. Okay, now we're going to look at bismuth and do the same thing. So right away, my number of protons always equals my number of electrons in a neutral atom. So we can say we have 83 electrons as well. So let's find bismuth and calculate our number of neutrons. So bismuth, where are you? So here's bismuth. So what we want to look at is the mass number, but we're going to round that. So 208 is going to round to 209, because if the number after the decimal is greater than 5, you have to round it to the nearest whole number. So it's 0.9, so that's going to round to 209. So we're going to take 209 and subtract our atomic number, the number above the symbol, 83. And we get 126. So we can find our number, 126, and drag it over. Okay, and now let's look at osmium, OS, and here it's telling us, okay, you have 76 electrons, so we also have 76 protons. Remember, they are equal in a neutral atom. So OS on the periodic table, here it is. So again, to find our neutrons, we want to take that mass number. So after the decimal, that's a 2. So this is going to stay at 190. We're going to take 190 and we're going to subtract the atomic number, the number above the symbol. So 190 subtract 76 equals 114. Okay, and then when we're looking at sodium, same thing. The number of protons always equals the number of electrons in a neutral atom. So let's find sodium and calculate the number of neutrons. So we're going to take the mass number, 22.9 is going to round to 23. So 23 subtract the atomic number, 11 equals 12. And then we're going to look at palladium, PD. But before we do that, remember your number of electrons equals your number of protons, always the same in a neutral atom. Okay, so PD. Let's see, PD. Here, it's PB, that's lead. We want PD. Here it is. So what we want to do is look at 106.4. That's going to, 4 is below 5, so that's going to stay at 106. So we're going to take the mass number now, 106, and we're going to subtract the atomic number, 46, and we get 60. And then lastly, we're going to look at strontium, and the number of protons equals the number of electrons in a neutral atom. So to find our number of neutrons, let's go to the periodic table and find strontium, which is here. So 87.6 is going to round to 88. We're going to take that mass number and subtract the atomic number, 38. So 88 subtract 38 equals 50. I'm going to drag and drop that over. And then lastly, what is the difference between the number of electrons in an atom of selenium and the number of electrons in an atom of aluminum? So we have to find these two elements on the periodic table and take the difference in the number of electrons. So selenium and aluminum. Okay, so here's aluminum. Let me find selenium. And here's selenium. So aluminum has 13 electrons, because remember, that atomic number tells you how many protons and electrons you have. And then selenium has 34 electrons. So we want to take 34, subtract 13. And we get 21. And then lastly, it says, what is the total number of protons, neutrons, and electrons for cadmium, Cd, an atom that has a mass number of 112? So let's go find cadmium with a mass of 112. Here it is. So my protons and my electrons are both 48. So I want to take 48 plus 48. That's going to be 96. Okay, and your number of neutrons. Remember, we want to take 112 and subtract 48. So 112 subtract 48 is going to give me 64. So I have 64 neutrons, 48 protons, and 48 electrons. So let's add that all together. And we get 160. Okay, let's see. The atomic number of krypton is 36. The mass number of krypton is 84. Which table shows the number of subatomic particles inside and outside the nucleus of krypton? So what you want to do is look at the data table first. The number of protons inside the nucleus. So to get the number of neutrons, we want to take 84, subtract 36, because this is your mass number and that's your atomic number. So mass number subtract atomic number. So 84 subtract 36 equals 48. So I would have 48 neutrons. So 48 neutrons plus 36 protons equals 84. So my number of particles inside the nucleus, remember your protons and neutrons are inside your nucleus. So I had to find out how many neutrons I had, and then this tells me how many protons I had. Number of particles outside the nucleus, those are going to be your electrons. And remember, your atomic number equals your number of protons and electrons. So C would be correct. All right, and going to the next slide, we're going to drag and drop the descriptors. It says this subatomic particle is used to identify an element. your protons identify an element. Here they're pointing to the positive particles. Your positive particles are protons. This subatomic particle is used to determine the reactivity of an element. That's going to be your valence electrons. The electrons in the outermost shell are your valence electrons. Here, that's a positive proton. This subatomic particle is the same as the group number. Your group number is the number above the periodic table, so the column. So this is your group number. Your group number is going to tell you how many valence electrons are in the outer shell. When you get to the teens, remember you're only looking at that second digit. So 3 valence electrons, 4 valence electrons, 5 valence electrons. Okay? So this subatomic particle has the same as the group number. Those your valence electrons are going to be the same as your group number, and you only look at the second digit when you're in the teens. 8 of these subatomic particles on the outermost shell make the element least reactive. Okay, so that would be your valence electrons. If you have 8 of them, it means you are stable, you're least reactive. This number increases as you move from left to right on the periodic table. That's your valence. Your protons increase in number as you go from left to right on the periodic table. So you see 24, 25, 26, 27, 28. The atomic number identifies the element. Every element has its own number of protons. Okay, and they increase left to right. And this arrow is pointing to the valence electrons, the electrons in that outermost shell. An element with very few of these subatomic particles are highly reactive. An element with very few of these subatomic particles are highly reactive. That's going to be your valence electrons. Remember, they want to have 8, so they're going to be reactive until they get 8. So valence electrons, this subatomic particle is located on the outermost energy shell. Okay, and going to our next slides. Here it says, what element am I? So remember, to identify an element, you need to count the number of protons. But if you can't identify which subatomic particle are the protons, you know your electrons equal your protons. So 1, 2, 3, 4, 5. If I have 5 electrons, I have 5 protons. So I would go to the periodic table and look for the element whose atomic number is 5. So I have 5 protons, 5 electrons. I'm boron. When trying to identify an unknown element, a scientist determines what other elements the unknown elements react with chemically. Which property of the unknown element determines the other elements it reacts with? These are going to be your valence electrons. Valence electrons are going to tell you its chemical reactivity, how it wants to react with other elements. Remember, if it has 4 valence electrons, it's going to try to get 4 more to have a full outer shell. Which element is being described by the data? So remember, your number of protons identifies an element. So if I have 37 protons, I want to go to the periodic table and find the element whose atomic number is 37. It's rubidium. And then based on these drawings, which element is least reactive? Remember, if you have a full outer shell with 8, it means you are not reactive, you're least reactive. So 2, 4, 6, 8. Neon is a gas, and we know that neon, being a noble gas, is unreactive. If you look at chlorine here, chlorine has 2, 4, 6, 7. It's highly reactive because it just needs 1 more valence electron to fill that shell. Okay, group 17. All right, let's have a look at these. It says, what does the atomic number on the periodic table tell us? The atomic number, the number above the symbol, tells us how many protons we have. Which particles of an atom determine what an atom will react with? That's going to be your valence electrons determine chemical reactivity. What element on the periodic table has 27 protons? So I'm going to look for the element whose atomic number is 27. It's cobalt. What number displayed on the periodic table indicates the number of protons? That's going to be your atomic number, the number above the symbol. Which element is more reactive, lithium or aluminum? So I'm going to go to the periodic table. Here's aluminum with 3 valence electrons, and here's lithium over here in group 1 with 1 valence electron. So lithium is highly reactive because lithium is in group 1 with 1 valence electron. And over here, aluminum had 3 valence electrons. So we would say lithium is more reactive. Will fluorine have more similar properties to oxygen or to bromine? So fluorine is going to be similar to what element? So we want to find fluorine, and fluorine is going to be similar to bromine because bromine is in the same group. So that means they both have 7 valence electrons in that outer shell. So I'm going to say bromine. Fluorine is more similar to bromine. So they're in the same group with the same number of valence electrons. What changes if you add the number of protons in an atom? Well, the type of element changes. Remember, every element has its own number of protons. Which is more reactive, chlorine or argon? So let's have a look. Here's chlorine. Chlorine is highly reactive because it's in group 17. They all have 1 valence electron. They have 7 valence electron. They only need 1 more valence electron to be full. So remember, group 17 and group 1 are going to be your most reactive elements. Which particle of an atom indicates how reactive the atom is? That's your valence electron. And what element on the periodic table has 8 protons? So if we go to our periodic table, we can see that oxygen has 8 protons because its atomic number is 8. That number tells you how many protons and electrons you have. Okay, we are almost finished. So it says here, which element has the same number of valence electrons as thallium? So I want to look for TL and see what element has the same number of valence electrons. Okay, so same number of valence electrons are going to be the elements that are in the same group. So whatever our answer choices are there, we have boron, aluminum, gallium. Let's see what we have. Boron looks good. What element am I? So remember, to identify the atom, you want to look at the number of protons in your nucleus. So it's telling us we have 11 protons. So if we go to the periodic table, we can see whose atomic number is 11. So it's sodium. What element shares the same chemical properties as this element? So chemical properties, you look at the valence electrons, the electrons in the outer shell. It has 1 valence electron. So this atom is in group 1. So we want to see what other elements are in group 1 that have similar chemical reactivity. So here we can see all of these are in group 1. So lithium, sodium, potassium. Okay, and what element am I? So here in the nucleus, they're not showing us our protons or our neutrons, and we know protons identify an element, but remember, If you can't determine the number of protons, your number of electrons equals your protons. So let's see here. I have 2 in the first shell, then I have 8 in that second shell, so that's 10, 11, 12, 13. I have 13 electrons, so I have 13 protons. So let's go identify the element. So the atomic number is 13. Okay, 13 protons, 13 electrons. And then which element am I? I can see that there's 17 protons. Remember, protons identify. So now I go to the periodic table and I look for the elements whose atomic number is 17. It's chlorine. And then which element am I? Again, we can't determine the number of protons that identify an atom. So the number of electrons equals your protons. I have 2 in the first energy level, then I have 8, so I'm at 10, 11, 12, 13, 14. So 14 electrons means I have 14 protons, so it's silicon. Okay, and then last question. It says the diagram shows a model of an atom. The model has 4 different symbols on it, X, Y, and Z. Each symbol represents a different role for one of the particles within the atom. In this model, which particle determines the reactivity of an atom? Remember, your reactivity has to do with your valence electrons, those electrons in the outermost shell. So that's going to tell you its reactivity. It has 1, 2, 3, 4, 5, 6. So they're in group 16. They have 6 valence electrons. They're going to react to try to get 2 more. All right. Well, I hope you enjoyed your lesson